to 4. So does anyone remember what two conditions have to be met for extreme value theorem to apply? Continuous and what was the other one? Yes, closed interval. So did they give us a closed interval?
Yeah.
Yeah, they said 0 to 4 with brackets. Okay, so now we just need to figure out which one of these is continuous. I see tangent of x, arctangent of x, and then a rational function, and we got another one with a fraction. Why don't we start here? What do you think we should do on these? Let's factor this one. We got x plus 4, x minus 4 over x plus 5 times x minus 4. Oh, what's happening? A whole at x equals 4, which is in my interval, so it can't be C. What do you think about D? No. Why not? X equals 0. If I plug in a 0 there, that would give me 1 minus 1. That gives me 0. So there's a vertical asymptote at x equals 0, which is also in the interval. So now it's between tangent of x and arctangent of x. All right, do we remember what those look like from pre-calc? What does tangent of x look like? Like whoop, whoop. What does it have? A bunch of vertical asymptotes. It has a bunch of vertical asymptotes. Do you remember what arctangent looks like? You take one of those, flip it on its side. I can't do it with my arms, but that's what arctangent looks like. So this one is the one that's continuous. Okay? All right, find the maximum value. When we're finding a maximum or minimum value, that's when we do our candidates test. So I'm going to make my table. What points do I need to check? End points and critical points. Critical points and end points. So yeah, I'll go ahead and put -1 and 2 on my table because I know I have to check those ones. What are critical values? Exactly. Find the derivative, set it equal to 0. Also, if it's undefined, that's also a critical value. All right, so my derivative here is 6x squared minus 18x plus 12. Can I get an undefined slope out of that? No, so let's just set it equal to 0 because that's the only way I'm going to get critical values. How about we divide that by 6? So x squared minus 3x plus 2 equals 0. Factor that. X minus 2, x minus 1, x equals 1 and 2. Those are my critical values. Do they fall within my interval? Yes, they do. Actually, 2 is already on the list over there. So 2 is taken care of. I need to add 1 to the list. So these 3 values we need to plug in where? To the original function. See what the y values are. When we find the highest one, that will be our maximum value. All right, so plug in -1 and tell me what you get. What? -24. All right, what do you get when you plug in 2? I think it's 3. And what do we get when we plug in 1? 4. All right, so read carefully. It says find the maximum value. What is the maximum value? 4. Maximum value, or you could say absolute maximum value is 4. If you choose to give additional information, you can say at x equals 1, that's fine. They didn't ask you for that. If you give additional information and it's wrong, then you lose points. So this is all you have to write. All right, here's one more of those. Where does the minimum value occur on the interval 0 to pi? All right, so again, I'm finding an absolute minimum or maximum. Candidates test. I'm going to go ahead and put my endpoints on the table, 0 and pi. Now I need my critical values. That is where the derivative is equal to 0 or undefined. So let's find our derivative. What is f prime of x equal to? Negative sign of pi x times pi. Can I get an undefined slope out of that? No, so set it equal to 0. Alright, how are we gonna solve this? What should I do first? I think we can get rid of this pi and the negative. Let's just divide by those. So now we have sine of pi x equals 0. Ooh, do we remember how to solve these? Yeah, I'm basically taking the arc sine of both sides, so I need to figure out where is the sine equal to 0? 0. Where else? Hi. So it needs to be taken down. I'm recording the lesson right now. Here, take one of these. Yeah. Progress checking. Yeah. Okay, so where is the sine equal to 0? We said 0. Anywhere else? Pi. And?
Get rid of the negative pi.
I divided by negative pi on both sides. Okay, so 0, pi. We could keep going, right? We can go on forever and ever because there's multiple places where the sign is equal to 0. So pi x equals, the question is, how many values do I need to list? Well, all of them would be forever. As 0, pi, 2 pi. Do we need the 2 pi? We only want values that are between 0 and pi, but we have one more step when we solve this. What are we going to do next? Divide by pi. So after I divide by pi, I want anything that will then fall in that interval. I'm going to go out a couple more. I'm going to do 3 pi, 4 pi, dot, dot, dot. All right, let's divide by pi. So x equals 0 falls within the interval. What about 1? Yes. What about 2? What about 3?
Yes.
What about 4? Pi is 3.14, right? So 0, 1, 2, and 3 are going to fall within that interval. So I can now add those to the list. 1, 2, 3. The next step is to start plugging these into the original equation. Alright, so if I plug in 0, cosine of 0 is 1. Cosine of pi squared, I don't know if I know that. Let's skip it and move on. 1, what's the cosine of pi? Negative 1. Okay, if I plug in 2, what's the cosine of 2 pi? 1. If I plug in 3, what's the cosine of 3 pi? Negative 1. Okay, so if we don't know how to evaluate cosine of pi squared, let's just pause for a moment. Cosine, think about what that looks like. Do we know what the absolute max and min values are of cosine? 1 and negative 1. Doesn't it go between 1 and negative 1? So we know the minimum value is negative 1. So I don't even really care what this is. It says where does the minimum value occur? So where does it happen? X equals 1 and 3. I like that question, by the way. Okay, now let's talk about today's lesson. I did not draw this up here. I drew it on yours. Did I? Something like that? What was this number? 3 and then 6 here?
Yeah.
Okay, that's supposed to go back up, by the way. And then I had like a 2 and a 4. Okay. All right, so without using calculus, you guys tell me, where is f of x increasing? Negative infinity to 3. Union 6 to infinity. Correct. Where is it decreasing? 3 to 6. Are there any relative maxes? Yes, and by the way, relative maxes and mins we're gonna give as a point. So the relative max is at 3, 4. We have a relative min. 6, 2. There you go. You already know all these terms. You already know how to find where it's increasing and decreasing. We're going to use calculus to find these things now. So what all of these have in common is they can be defined by their slopes. So what do you know is true about the slope if it's increasing? It's positive. Decreasing means the slope is negative. What about maxes and mins? The slope is 0. So how do I know which one is which if I know that the slope is 0? Well, look at our relative max. What's happening around it? It's going from a positive slope to a negative slope. And our minimum is going from a negative slope to a positive slope. There you go. That's how we're going to define all of these terms. And you have that written down on your notes. You're welcome. You don't have to write all of this down. These are our justifications. Anytime you see the word justify and it's one of these, you're going to use this. Okay? F of x is increasing because f prime of x is greater than 0. F of x is decreasing because f prime of x is less than 0. Relative max at a point because f prime of x goes from positive to negative. Minimum because it goes from negative to positive. Critical values, you already know this. X values where the slope is 0 or undefined. Every relative max or min comes from a critical point. However, not every critical point will give you a local max or min. All right, we got 2 problems we're going to do. Find intervals of increase and decrease. Identify the coordinates of all relative extrema. Justify using calculus. We're going to find our derivative first. F prime of x equals 3x squared minus 3x. To find critical values, that's where the slope is 0 or undefined. Can I get undefined out of this? No. So let's set it equal to 0. What do you think we should do now? Factor out of 3x. So that gives me x minus 1. So my critical values are 0 and 1. Alright, I'm going to make a little number line over here to the side. This is called a sign line. S-I-G-N, not S-I-N-E. And I'm going to put my critical values on here. Your sign line is for you. It is not a justification. It's not work that would be graded on an AP exam. This is just a helpful tool for you. I like to put negative infinity and infinity on there too. Alright, what we're going to do is we're going to test in between each of these intervals to see if the slope is positive or negative. So pick a number between negative infinity and 0. How about negative 1? Alright, so I'm going to take negative 1 and I'm going to plug it into the derivative. You can use either one. I always do the factored one. It's easier. Because then I'm just saying, okay, if I plugged in negative 1 here, that would be a negative number times a negative number, right? So that's positive. I just want to know if it's positive or negative. I don't care what the number is. Alright, then a number between 0 and 1 would be like a half. So if I plug in a half here and a half here, that would be positive times negative. So negative. And then something bigger than 1, let's say 2. If I plug that in here, I'd have positive times positive, which is positive. Now I can look at this and see where is it increasing. Negative infinity to 0 and 1 to infinity. I can see it's decreasing from 0 to 1. If you want to, sometimes I'll draw these little lines going the direction like positive, negative, positive. Then you can visually look at it and see, okay, do I have any relative maxes? Yeah, at 0. And then I have a relative min at 1. Okay, so this is just a little helpful tool. By the way, I think it's funny that coincidentally I taught multiplicities yesterday in Algebra 2. Do you guys remember this?
Yeah.
Like the multiplicity of the 0, if it's an odd number, it crosses over the x-axis. If it's an even exponent, it bounces. So you can also use multiplicities to help you fill out this sign line. Once I find the first one, at x equals 0, the exponent here is odd, so I know it's going to switch to negative. At x equals 1, this exponent is also odd, so I know it's going to switch to positive. We'll do another one and I'll show you how to use multiplicities, but let's finish answering these questions. Increasing, you said, was negative infinity to 0. Union 1 to infinity. it says justify all answers, so I'm gonna write because f prime of x is greater than 0. You guys said it was decreasing from 0 to 1 because f prime of x is less than 0. We said there was a relative max at x equals 0, but I need a point. So how am I gonna get the y value of the point? Plug it into what? Original, the f of x. Anytime you're finding a point on the graph, you plug it into f of x, not the derivative. That would be 0. Justification is because f prime of x goes from, what is it, a max positive to negative. And we also have a relative min at 1. What's the y value for that one? Plug in 1, what is it? Yep, negative 1/2, because f prime of x goes from negative to positive. Okay? Alright, one more, real quick. They were nice and they gave us the derivative. Notice it says f prime of x equals, so they've already got the derivative and it's already factored. So we can go straight to finding our critical values. What are the critical values? 0, negative 3, 3, and 5. There we go. Let's make our sign line. Negative infinity, positive infinity. Let's make sure I put this in the right order. Negative 3, 0, 3, 5. All right, let's plug in something smaller than negative 3. How about negative 4? If I plug negative 4 into this, it's squared, so that's going to be a positive, right? Let's see, this one, negative 4 plus 3 to the 4th power, the even exponent will still make it positive. What about this one? That's going to be negative. What about the last one? Positive. So positive times negative times positive. What do we have? Negative. Okay, I don't want to keep doing that for every interval. Here's where you want to use your multiplicities. At x equals negative 3, let's look for negative 3. That's right here. We have an even exponent. That means it's going to bounce, so it will stay negative. We're not changing signs. What about at x equals 0? Are we going to change signs or stay negative? Stay negative. That one's squared. It's still going to bounce. What about at x equals 3? Negative or positive? Yep, it's x equals 3 is right here. The exponent is odd, so we're going to switch to positive. And what about at x equals 5? Are we going to stay positive or switch to negative? X minus 5 squared is going to stay positive. It's going to bounce. Okay, so increasing, decreasing. Where is it increasing? What do you think? Increasing would be 3 to infinity. I know you're sitting there like, well, what about 5? The slope is 0 at 5, right? Isn't that neither increasing nor decreasing? Well, I said every critical value, something's happening there. It's just not changing to decreasing. Think about y equals x cubed. Wouldn't you say that that's increasing the whole time? So the slope is actually 0 at that point, but we still say the function's increasing because every point is higher than the one before it. So if it doesn't change signs, just don't worry about that number in between. So 3 to infinity is increasing because f prime of x is greater than 0. And where is it decreasing then? Negative infinity to 3 because f prime of x is less than 0. Do we have any relative mins or maxes? Relative min. Yes, at x equals 3, and normally we ask for a point, but you don't have the original function. We only got the derivative, so they're only going to ask you to find the x value of any extrema. So relative min at x equals 3 because f prime of x goes from negative to positive. There you go. Okay. That is it. You guys have worksheet 2 to get started on. There is a progress check in AP Classroom. That's your Monday digital learning day assignment. It's already open though, so if you want to do it early, you can.